Theory of probability. We all know that statistical inference and decision theory are essential tools of the analysis of most of the modern business and economic problems. In this lesson, we will discuss probability, counting techniques, modern approach of probability, and understand various theorems of probabilities. After going through this presentation, you should be able to define probability, explain permutation and combination, describe modern approach of probability and various theorems of probabilities, and understand various theorems of probabilities. If n is the number of equally likely, mutually exclusive and exhaustive outcomes of a random experiment, out of which m outcomes are favorable to the occurrence of an event A, then the probability that A occurs, denoted by PA, and equals to number of outcomes favorable to A divided by number of exhaustive outcomes. The classical theory of probability applies to equally probable events, such as the outcomes of tossing a coin or throwing dice. Such events are known as equipossible. Equally likely outcomes are the outcomes of random experiment and are said to be equally likely or equally probable if the occurrence of none of them is expected in preference to others. Mutually exclusive outcomes are the two or more outcomes of an experiment and are said to be mutually exclusive if the occurrence of one of them precludes the occurrence of all others in the same trial. Exhaustive outcomes are the totality of all possible outcomes of a random experiment. The occurrence or non-occurrence of a phenomena is called an event. Now in this example, we have to calculate what is the probability of obtaining at least one head in the simultaneous toss of two unbiased coins. Solution. The equally likely, mutually exclusive, or we can say exhaustive outcomes of the experiment are HH, HT, TH, and TT, where H denotes a head and T denotes a tail. Thus, n equals to 4. N is the total number of occurrences. Let A be the event that at least one head occurs. This event corresponds to the first three outcomes of the random experiment, because the fourth one doesn't contain any head. Therefore, m equals to 3. Hence, probability that A occurs is equals to 3 divided by 4. The permutation of a number of objects in the number of different ways they can be ordered, that is, which is first, second, third, etc. If you wish to choose some objects from a larger number of objects, the way you position the chosen objects is also important. With combinations, on the other hand, one does not consider the order in which objects were chosen or placed. The ability to count the possible outcomes in an event is crucial to calculating probabilities. A permutation is an arrangement of a given set. Permutations of n objects is equals to n, n-1, n-2. 3.2.1 equals to n, and combination represents the number of combinations of n objects taking r at a time. Number of combination equals to total number of permutations divided by number of permutations of each set. Question is, 3 prizes are awarded, each for getting more than 80% marks, 98% attendance and good behavior in the college. In how many ways the prizes can be awarded if 15 students of the college are eligible for the 3 prizes? Here R represents number of prizes. All the 3 prizes can be awarded to the same student. The prize for getting more than 80% marks can be awarded in 15 ways because there are 15 students, and prize for 90% attendance can be awarded in 15 ways, and prize for good behavior can also be awarded in 15 ways. Thus, the total number of ways is n to the power r equals to 15 to the power 3 equals to 3375. A committee of 8 teachers is to be formed out of 6 science, 8 art teachers and 1 physical instructor. In how many ways the committee can be formed if A. Any teacher can be included in the committee. B. There should be 3 science and 4 arts teachers on the committee such that any science teacher and any arts teacher can be included. Solution. Here, total number of teachers are 15. We have to form a committee of 8 teachers so that in first, any teacher can be included to the committee. Therefore, 8 teachers can be selected out of 15. In 15C8 equals to 15 divided by 8, 7 equals to 6,435 ways. In second case, 3 science teachers can be selected out of 6 teachers in 6C3 ways, and 4 arts teachers can be selected out of 8 in 8C4 ways, and the physical instructor can be selected in 1C1 way. Therefore, the required number of ways equals to 6C3 into 8C4 into 1C1 equals to 20 into 70 into 1 equals to 1400. If an experiment is repeated n times under essentially the identical conditions, and if out of these trials an event A occurs m times, then the probability that A occurs is given by PA, which equals to limit from n to infinity of m divided by n, it provided the limit exists. This definition of probability is termed as the empirical definition because the probability of an event is obtained by actual experimentation. It suffers from the following shortcomings. First is the conditions of the experiment may not remain identical, particularly when the number of trials is sufficiently large, and it may not be possible to repeat an experiment a large number of times. Let S be a sample space of an experiment and A be any event of this sample space. The probability of A, denoted by PA, is defined as a real value set function which associates a real value corresponding to a subset A of the sample space S. The first axiom implies that the probability of an event is a non-negative number less than or equal to unity. The second axiom implies that the probability of an event that is certain to occur must be equal to unity. Axiom 3 gives a basic rule of addition of probabilities when events are mutually exclusive. The axioms provide a set of basic rules that can be used to find the probability of any event of a sample space. 4 theorems on probability. First theorem, P null equals to 0 where null is a null set. Second theorem is PA equals to 1 minus PA where A bar is a complement of A. Third theorem is for any two events A and B in a sample space S, and the fourth is addition of probabilities. Thomas Bayes addressed both the case of discrete probability distributions of data and the more complicated case of continuous probability distributions. PA oblique B equal to PB oblique A multiplied by PA divided by PB. We have to calculate that what is the probability of drawing a black card or a king from a well-shuffled pack of playing cards. Now, there are 52 cards in a pack, therefore total sample space equals to 52. Let A be the event that the drawn card is black and B be the event that it is a king. This means we have to find probability of A union B. We all know that there are 26 black cards in a pack and 4 kings in a pack. This means probability of A equals to 26 and B equals to 4. And the probability of intersection of A and B is 2 and NS. Thus probability of union of A and B by putting values in formula PA plus PB minus PA intersection B divided by NS, which equals to 7 divided by 13. Now let us check if we have understood the various concepts discussed in this lesson clearly. A probability of getting the digit 2 in a throw of unbiased dice is 0. Right or wrong? Wrong. The collective exhaustive list of outcomes to an experiment contains every single outcome possible. Right or wrong? Right. When someone says that the probability of occurrence of an event is 30%, he is stating a classical probability. Right or wrong? Wrong. Before we end, let us briefly revise what we have studied till so far. The probabilities assigned to various events on the basis of the conditions of the experiment or by actual experimentation or past experience or on the basis of personal judgments are called prior probabilities. A sample event is the basic possible outcome of an experiment. It cannot be broken down into simpler outcomes. Event can be defined as any set of all possible outcomes or simple events of an experiment. Probability is a numerical measure of the likelihood of occurrence of an uncertain event. Conditional probability is the probability of an event occurring given that another event has occurred. Bayes' theorem is a method to compute posterior probabilities.